Okay, Brill, I'm going to go through these questions now really quickly. So I'm going to start with 13b, and I've already sent you some photos, but anyway, this will work. Here we go. So the first one, we had to differentiate y equals log to the base 2, log to the base x of 2. And I immediately thought, I'll change the base of this, but not change the base, but rewrite this in a different form, but it was never going to work. But then you know that you can take any log. So I'm going to take ln of 2 over ln of x. And that comes from this law that log of a over b equals any log of the same base over the top. So once you get that, you're away. So all you have to do is, I rewrote this as, I used the quotient rule, so it's the bottom, ln x times the derivative of the top, which is 0, because remember ln2 is just a number, minus the top, which is ln2, times the derivative of the bottom. The derivative of ln x is 1 on x, all over the bottom squared, which is ln x all squared. And that'll give you negative ln2 over x over ln x all squared. And then when you multiply by the reciprocal, that's just going to be minus ln2 over 2x times ln x all squared. So that's that one. The next one, question 17c. All right, this is a very difficult one. I had to try and check it on Desmos. So we've got, 17a, 17. So we're going to do a. So we've got y equals x minus 5 ln x. And the derivative of that, well, the derivative of x is just 1 minus the derivative of 5 ln x is just 1 on x, so I'm going to get 5 on x. And if I differentiate, I'm going to rewrite that as a power, so 1 minus 5x to the minus 1. Now I derive that again, I get y double dash, and I'm going to get 0 minus 1 times minus 5, so minus 1 times minus 5. Take 1 away from the power, x to the negative 2, which gives me 5 on x squared, because the negatives will cancel, the x will go downstairs. Now, what do we do with this? Stationary points occur when y dash equals 0. So 1 minus 5 on x equals 0. 1 equals 5 on x. X equals 5. Well, let's find out what y equals. Well, y equals 5 minus 5 ln 5, which is, what is it, minus 3.0472. Now, so we've got this coordinate 5 and minus 3.0472. And what does y double dash equal? Well, y double dash equals 5 on 5 squared, which is 5 on 25, or a fifth, which is greater than 0. Therefore, a max, min TP, a minimum turning point. Now, so that's 5a and b, so we differentiated and we found the stationary points. Well, it says C, comment on the concavity. Well, the thing that tells us the concavity is the second derivative. And the second derivative equals 5 on x squared, which means that the second derivative will always be greater than 0. It can't equal 0 because you can't divide by 0, so it has to be greater than 0. And this means, therefore, it's always concave up. Always. concave up. And hence no points of inflection. Also, we need to know that y equals x minus 5 ln x. And we know that for this to be true, x must be greater than 0. So we know that it doesn't go anywhere to the left. So now we've got a few things that are going to help us sketch this thing. So where are my shapes? Let's get myself a x and y plane. Let's make that black. Righto. So what do we know? We know that it can't touch this. It can't touch that. It's going to approach it. And I'm just going to get my calculator up. If I can find it. I'll just download it. Where is it? Is it on my desktop? There it is. Right. So you can just plot points, but what do we know? Well, we know that we've got a turning point at x equals 5. So I'm just going to go 1, 2, 3, 4, 5, about there. And down here at 1, 2, 3. And it's negative 3.0. So it's going to be pretty close. So there is our turning point. And that's x equals 5 and negative 3.0. What was it? 472. And it's important to label that. Now we know that it's always concave up. And if I get my calculator back, and if I go in here and I go, all right, I want to find out what happens as it gets closer and closer to 0. So I'm not going to go through all of them, but I want you to do this as well. So you get 0.00001, make that my answer, and then I use my, I go answer, was it? Answer minus 5 times ln of my answer. Close that bracket. And I get 69. So this curve is shooting up there. I can put in more values, and that's what I mean by plotting points. So now I just plotted points. I'm going, all right, well, where is this coming down? Where is this going to be? So that's x getting really close. Let's go x to the half. So if I just go 0.5, hit return, go up. I get that again, hit return, 3.9. So I'm getting all these points. I'm going to write them in here, x and y. So I've got a half, and what do I get? 3.9, 3.97. And if I go back, and now I'll try something else. I don't know. I'll try 1. So if I go 1, enter, and I go up, and I hit enter again, I get 1 and 1. Oh, so 1 and 1. So here I've got 1 and 1. So it's going through there. So I'm going to tidy this up a bit. And I just plotted a heap of points. And that is how I guessed where it was going to go through. Now, the problem is, this is not a parabola. Even though it's always concave up, it's not a parabola. It's approaching that, and then it skews off like that. And to find these 2 points, which is pretty important, but I don't know if your teacher's going to want that. I just kept guessing, and I kept going, and eventually, at this point, I got as close as 1.29. Now, this one, I got 12.7 something. And I just kept pumping numbers into my calculator using that to get closer and closer to when it equaled 0. I don't know if they're going to want you to find those intercepts, the x-intercepts, but that's a pretty good effort, I reckon, if you can get that. And also finding out what happens as x approaches 0. So what you're going to write, as x approaches 0 from the positive side, so 0.000001, y approaches infinity. And then you could also go, as x approaches infinity, y approaches infinity, because it's just going to keep going up and up and up and up and up. And they said for the domain, but I didn't sketch it for the values that they said, and then find the global maximum and minimum, but you should be able to do that. I mean, the global minimum is going to be negative 3.0472 because what do they want you to sketch it between? I've lost the question. I thought it might have been. Hold on, I'll get it up on my other computer. And what was it? I think it was 1 and something. So where is this question? So that one? No, it's not that one. Sorry, Brielle. That's not that one. That's that. Come on, where are you? Yeah, between 1 and 18. So you get 1 and 1. So it's going from that point. And then 18, let's find out what it is. So if now I just type 18, hit that as my answer, use my up arrow, press return. That doesn't seem right. Yeah, it might be. So at 18, let's say this is 18. And this is, so there you put that dot, that, and this, and you watch, this is I'm gonna lose that now. And then that goes to there. And this is 18, and what did we get? 3.5. And we got 1, 1. So the global minimum is y equals negative 3.04, and the global max is y equals 3.5. Yeah, so that was 17. Question 19. What do we got? So we got this triangle. Now, I was a bit worried about this because I thought you'd be able to do this. But that's not what inscribed means. Inscribed means it touches all edges. So let's get rid of that and go, okay. So it's going to go down here. It's going to hit that base. Geez, that looks like a square. Anyway, it'll do. And we know that that's 70, that's 50, that's a right angle. We're going to call this X. We're going to call this Y. Let's label this triangle A. I'll call this one B, C, because we're going to use similar triangles. And we're going to use, hold on, get the pen, D, E. So now, draw those two triangles separately. So I'm just going to draw ABC. So that's 90. That's that dot. That's that dot. And if you've got two angles, so this is A, B, C. Now I'm going to draw the big one. If you've got two angles, you've got all three. That's a dot because it's common. That's 90. Call that X. Well, that's X. And that's A, D, E. Well, triangle A, is similar to triangle ADE because they're equal angular. So we know that they're equal angular. Now let's have a think. That's 70, that's 50. Too easy. This distance here, all right, this distance here is 70 minus this bit. So 70 minus x. And this distance here is y. So therefore, because the two triangles are similar, their sides must be in ratio. So you can go y to 50 equals 70 to, come on, do it the right way. 70 minus x over 70, and then you're just going to multiply the 50 over. 50 over 70 times 70 minus x, got to have that in brackets, becomes 5 on 7, 70 minus x, which is what you needed. You could have also said, and that's what I said in the photo, that, because the two sides are in ratio, y to 70 on x minus x equals 50 on 70, and then multiply it over and you get the same thing. 5 on 7, 70 minus x. Now, once you know that, it becomes rather easy. So, let's go, I'll go down here. The area of the rectangle, I'm going to make this a bit thicker, equals xy. Well, we've got x, and now we've got y over here. So just sub that in, times 5 on 7, 70 minus x. Okay, so 5x on 7, 70 minus x. So you get 5x times 70 on 7, so the 7s will cancel, I'll get 50x, minus 5x squared on 7. Now, I'm going to differentiate. So I get a dash is 50 minus 5 on 7. Got to multiply by the 2. So 2 times 5 on 7x, so that becomes 10 on 7x. I'm going to differentiate again, and I get negative 10 on 7. So what do we know? There's a possible min-max when a dash equals 0. So that means 100 and... come on, give me my rubber. That means that 50 minus 10 on 7x equals 0. So 50 equals 10 on 7x. Divide by the 10, that comes 5, and times by the 7. So, and I get 35 equals x. Well, 35 equals x, y equals, what was it? 5 on 7 times 70 minus x, which is 5 on 7 times 70 minus 35, which equals 5 on 7 times 35. 7 goes in that, so I get 25. Now, you have to state whether or not it's a max. So it is a max because a double dash equals negative 10 on 7, which is less than 0, therefore a max. And if you want to find the area equals xy, which equals 25 times 35, which is 875 centimetres squared. All right, the last one. And now I'm going to have a break after that. Let's have a look here. So it's important you do this because you have a skill, hopefully you've done it. Yeah, I think you've done it, called integration by substitution. So this is how I would do it. And they say use the reverse chain rule, and you can use your formula set. So you've got 1 and 0, and you've got minus 6x squared on the square root of 4 minus 2x cubed dx. Now, when you start getting these and you're thinking about substitution, what you're looking for is you're looking for the derivative of what's in here. And the derivative of what's in there is 6x squared. And we've got that, or negative 6x squared, and that's on the top. So this is how you should do it. I don't know if your teacher does this. I'm going to let u equal 4 minus 2x cubed. And du dx equals minus 6x squared. Therefore, du equals, now even though a lot of people write du dx as a fraction with the vinculum in there, it's not a fraction, but it acts like a fraction and it has all the properties of a fraction. Anyway, I'm going to take that dx over to the other side and I get minus 6x squared dx. Now this is important because I need this in my new integral. And my new integral is going to be, and note, I haven't written any of the parameters. I'm going to leave that and you'll see in a minute. So I'm going to separate this out now. So I'm going to get 1 over the square root of 4 minus 2x cubed times minus 6x squared dx. And you can see that that's going to become du. Okay, so I'm going to get 1 over the square root of u du. And now I can integrate it with respect to u. And it's a really easy integration. But I also want to find when x equals 1, well, u equals 4 minus 2 times 1 cubed, which is 4 minus 2, which is 2. And when x equals 0, u equals 4 minus 2 times 0 cubed, which is 4 minus 0, which is 4. So I don't even need to put it all back. I'm just going to go from 2 to 4. I've now got new parameters. I've changed the whole thing. And now it's really easy. 2, 4, u to the negative a half du. Wow. Add 1 to the power, u to a half. Multiplied by the reciprocal of the power, or divide by a half, 2. What's it between? 2 and 4. What do we do here? Okay, that's 2 root u, 2 and 4. Oh, integral. So that's going to be 2 root 2 minus 2 root 4. Oh, 2 root 2, no, I'm not touching that, minus 2 times, root 4 is that, which gives me 2 root 2 minus 4, and I can rewrite that as minus 4 plus 2 root 2, which is what they wanted. Sweet. All right, that'll do for now. I'm going to send you a link with this on YouTube.